So we're first going to look at things about 8.1, looking at how to draw the gradient curve. So we'll look at the first question. What's the derivative of the straight line at each of these x values? Let's start with -2. So at -2, what's the gradient there? No, if you draw the triangle, the gradient is 2 over 1, gradient is 2, right? And what's the gradient at 0? Also 2, right? It's always 2 for a straight line. How about the gradient at 2? It's still 2, right? The gradient of a straight line is always 2. So in that sense, when you get a straight line, yeah, if you're going to draw the derivative, y equal to f dash, it's always going to be 2. So if you plot the point 2, then you just get a higher line, right? No, it will be 3 or 4, whatever the line is. Okay? All right. Well, for this line, it's always 2, no matter where you are on no matter what the x values are. Okay? All right. How about the parabola? We learned something about parabola before. Now, what's the derivative of the parabola? 2x, which means that I could calculate the gradient at each point. So what's the gradient at -2 if you use this formula? -4. So that means at this point, at the point -2, the gradient is -4. So I plot the point there, -4, right? How about the gradient at 0? 0. And the gradient at 2, 4. So I plot the point 4. Does that make sense? Yeah. So if I join the points, what do you get? You get a line like this. That's the graph of the derivative. Right? Alright, good. So now you know how to draw the graph of the derivative for a parabola, for a straight line. Let's look at a more complicated curve. Let's look at part D first, then we'll look at part C. Okay, part C is a little bit complicated. Alright. Okay, so hopefully you're ready. For part D, we're going to show you an animation which I have available. Okay, so let's look at this. So we're going to draw the gradient graph for this. So if you've done the homework, you should know what it looks like. If not, we're going to look at this. So I've drawn the graph on GeoGebra. This is the same graph, right? We're going to draw the graph of the tangent. So basically, let's not put this on. So as I move the point A, the gradient of the tangent changes. Agree? Right? So let's look at it more closely. So let's enlarge it. Okay, so B's represent the gradient. So watch what happens when A is at this position. What's the gradient there? 0. So B is on the x-axis, yes? And what happens if I move the point to the left? The gradient becomes negative. So you see, B goes below the x-axis. Does that make sense? So the B maps the gradient of the tangent as the point A moves. Yes? So what happens if I move to that point again? Gradient 0 again. And then gradient becomes positive. Now, let's put the trace on. You can see what the graph of the derivative look like. So watch this. This is positive gradient. And then, as the A moves to the point, it becomes 0. Right? 0. And then what happens after that? It goes down, become negative gradient, and then move to a minimum value of -1 before going up again, but still being negative, and then 0, right? And then positive. Does that make sense? So I'm drawing the graph of the derivative, right? So what's the key idea there is that at the stationary point where the gradient is 0, that's where it crosses the x-axis. Yes? And then when the gradient is negative, when the graph is decreasing, the gradient graph is below the x-axis. And then when the graph is increasing, the gradient is above the x-axis. Okay, let's try to draw it. So we'll go back to this question. Okay, watch this. At that point, the gradient is 0. So let's put a dot there. Below the stationary point, the gradient is 0. That's all we know so far. And the other point, the gradient is 0. Yes, as we saw from the animation. Well, that we really don't know. So we just have to draw a rough sketch. That you don't have to be exact. So when the graph is going down, look at this section. I'm going to use a highlighter. So let's use a highlighter. So this section here, which I highlight, is going to be negative, right? So what we do is I'm going to draw below the x-axis. I'm going to use a red one. That's below, right? See the red bit? It's going below, making sure the 2 points are joined. And then after this, the graph will be going upwards. So this part here. See, this part is increasing. Right? This part is increasing. So since it's increasing, the gradient graph will be above the x-axis. So let's continue there. So we're going to go above. Right? Like this. And this part on the left, the gradient is positive. It's going to be above. So basically, let's summarize what we just said. Graph increase, gradient above x-axis, gradient graph, right? If the graph decreases, it's below. That word is very bad. Graph decreases, the gradient graph that we're drawing will be below x-axis. And of course, if it neither decrease or increase, will be on the x-axis. Does that make sense? So above, increase, below, decrease, and neither increase or decrease, or stationary, then you say on the x-axis, on x-axis. Okay, so that's the summary there. Yes? All right, good. Let's do this one, then we move on. Actually, we'll leave this one later. This one will come later. This one you may find a bit tricky, so we're going to look at that later. So we're going to move on to the next page. So how long has I been speaking? Right, 7 minutes. Okay, that's good. Okay, any question? Let's move on to the next page. We'll come back to that later. Okay, so, oh, it's already written here. I forgot about it. So let's highlight this. That's good. Oh, I didn't even know that I wrote it down here. Okay, that's good. All right. Okay, let's move on. So can you try this question? I'm going to guide you through this one, and then you're going to do some practice question. Okay? I'm going to show you. It's very easy. This is the easy part of the course. Now watch this. Following the guideline above, your first step is find the stationary point. Where are the stationary points? Here and there, right? So what do? Directly below that point, put a point on the x-axis, gradient 0. Gradient 0. Does that make sense? Dot, dot, dot. That's your first step. And then in your textbook, you will see that when it is plus, means the graph is going upward. What happens when the graph goes upward? It's going to be above, right? Yes? And what happens when it goes down? The graph will be below. See, I drew it? Does that make sense? So when the graph is decreasing, the gradient graph will be below the x-axis. Yeah, hi. Yep, thank you. Yep, I will pause. Can you try the next one? Give me a minute or so. You've already done it. All right, so you're pretty good. All right, so try the next one. Have a try. 1 minute. I will go through the answers. Alright, so basically start with 0. So that's going to be here. And then increasing. I'll leave that detail to you. And that's decreasing. Okay? And remember, it's a parabola. It's going to be a straight line when you draw it. It's not going to be a curve. So what do? Count to 5. 1, 2, 3, 4, 5. Yep, people got it. So it's above, and that's below. It's going to be straight. Perfect. Got it? Now, it's a straight line because when you differentiate x squared, you get line, right? Okay. All right. Now, I made some worksheet for you. The next page have a lot of questions. So, you could try to do this. Now, you will do it. And how do I know if it's correct? Look at the next page. The dotted line is the answers, okay? Why don't you just do one, see if you get it right, and then we'll start the next section in a minute. Okay? Take a few minutes to do. Seriously, bring something to school, useful, every day. Page 9. Okay, limits. You've done this before. What do? You have to do some algebra. Lim x approaches to, factorize the top. How do you factorize the top? Huh? Say again. Just tell me. Oh, no, this one you can't split. That's a good question. Now, you can only split if a question looks like this. There's one term. It's split, right? Do not do this when it's like that. When it's two terms, never split. Okay, so what would you do there? How you have to what? Factorize. So what's the factorization? I know, but tell me. So what would that be? So x what? X not minus 1, x plus 1. And usually you will find things that cancel. Now you must cancel before you substitute, because what will happen if you substitute straight away? That's it, which you can't do. Excellent, see? That's good. You learned something very good. Okay, now, what would you do? 2 plus 1. Now you substitute. The answer is? Okay, can you try the next one? Alright, show working, please. You have to show full working in the exam. Okay, I need to say something very important. Hopefully you're all ready. Let's do this one. Lim h approaches 0. Take the h out. H is common. And then h gets cancelled. Then you substitute. Let me write this again. Lim h approaches 0, 2x minus h minus 3. Put 0 into h, not x. So you must write the x, but replace the 0, put that 0 into h. Get it? And what do you get? 2x minus 3. Got it? Alright, try the next one. The next one's a bit different. I will show you. And then we'll do differentiate by first principle. Okay, let's start. Got it? Now this one, what you do is this. I need to tell you something. Delta x approaches 0. Now that delta x squared means delta x all squared. That's how they write it, okay? They leave out the bracket. So when you factorize out the delta x, write 3x squared. See, this is delta x squared, means there's two lots of it. So you only have one delta x left. Get it? Minus 5, close bracket, over delta x. And then what do you get? You get cancelled. Okay, what do you do next? You substitute. Because you get this question in the textbook. So now you know how it works. But some of you have done it already, I think. Let's put 0 in. So every time you see delta x, you substitute 0. So the x squared stays as x squared plus 0 minus 5. And the answer is 3x squared minus 5. Okay. Right, now we get to the exciting bit of differentiating by first principle. And you will get a question on that in the exam for sure. Yeah, I don't think they will ask 2 questions. Yeah, one question. It's usually about 3 marks. So if you know that, 3 marks for free. Guaranteed. All right, okay, ready? 1, 2, 3. I'm going to move to the next page. Talk about differential by First principle will take about at least 15 minutes or maybe a bit more. 1, 2, 3, go. All right, next page. On page 10. Now, before we do that, let's link to our previous knowledge. The question is, how do I find the gradient at 3? What is it? How do you find the gradient at 3? Huh? How do you know that? Yeah, but that's the y value, not the gradient. How do you find the gradient? We look at the derivative, right? And then substitute 3, and what do you get? Huh? Say again? 6. Okay, so that means if I find the point 3, which is that point here, that gradient is exactly 6. Does that make sense? So we've done that many times. We know how it works. But the question is, how do we know this is the formula? We somehow just assumed it, right? But how do I know that? How do I come up with that in the first place? Anyone remember? That worksheet, right? Remember that worksheet? I remember, like, if I drew it, that worksheet have a lot of tangents drawn, right? We just have to count the grid. But the question is, that's done by the computer. How does the ancient people do it? How do people 200 years ago or 300 years ago find out this formula without a computer drawing and measure the gradient? They don't have a computer. So that's what the differentiation by first principle. So that's how it was first discovered. Using this way to find out why this is 2x. Okay, so basically we use a computer, but there's no computer before. How do I do it without? So that's what we're going to find out on the next page. Okay, there's an animation which I didn't open. All right, doesn't matter. Okay, let's watch this. Watch. There's a graph in front of you. Let's watch what happens. So we're going to find the gradient of this line at 3, right? Which is, I know, the black one. But you look at the screen. That's what I'm teaching you. Okay, the black one, right? Now watch. These are the red one. The red one. Watch what happens. So the red one is getting closer and closer to the black one, right? Yes. So how do I make it closer? Is by making Q1, Q2, Q3, Q4 as close to P as we can. So we draw all these secant. Each time we make Q1, Q2, Q3 closer to P, the gradient of this secant getting closer to the tangent. Yes? So we're going to find the gradient of each. And to do that, we're going to find the y value. Let's do that. You need a calculator. If you need a calculator, come to the front. Anyone? Okay. Get a calculator out. Fill out this table of values. There you go. Yep. Anyone? Calculator? All right, let's start now. Okay, let's start with this. Okay, 3.5. I just want you to get the y value. So watch this. Just go 3.5 square. Square. What do you get? 12.25. Do the next one. 3.1 square. 9.61. Do not round. We need to take the whole thing. There's good reason we do that. 3.01 square. 9.0601. Make sense? Can you do that? Do it for everything. Do not round. You must use the whole thing. There's a reason I want you to do that. We need to be 100% accurate. 9.006001. I think there's a pattern, but that's not what we are concerned with right now. Just write down the numbers. The last one just 3. Oh, so I could just do it 9. Okay, good. Okay, so what? 3 square. Okay, all right, good. All right, Q4. Now Q4, can you write down the corner of each? So Q4 is 3.001, comma 9.006001. Okay. Q3 is 3.01, 3.01, 3.01, comma 9.0601, and Q2, what's Q2? 3.1, 9.61. Okay, 3.1, 9.61, and Q1 will be 3.5. Just label it there so you can visually see what they are. 12.25. Cool. Okay. As you can see, Q4 is almost exactly same as P, right? They are right next to it. Yep. Okay. We're going to find the gradient of each. Oh, I didn't label the subscript. How come it's not labeled? Anyway, can you label this? So this is gradient of PQ1. This is PQ2, PQ3, and PQ4. Okay? Write it. Did you write it? That was quick. Okay, after we do this, we're going to find the gradient. So let's find the gradient of MPQ1. So use the gradient formula. I'm only going to write it once, y2 minus y1 over x2 minus x1. We're going to do that. Okay, so y2 minus y1, Q1 is this one. Okay, so you have to do 12.25 minus 9 over 3.5 minus 3. Now, I don't want you to do the whole thing on your calculator, rather show all the steps. There's good reason why I want you to do this. Oh, whoops, yeah, I'll do that again. Alright, minus 9, you get 3.25 over 0.5, right? Then do it on a calculator. I want you to see everything, the exact reason. Okay, what's that? 3.25 divided 0.5, what do you get? You get 6.5. Okay, so the gradient of this line, the red line here, is 6.5. Yes? Okay, good. Try the next one. Can you do MQ2 and alright, let's continue. MQ3 and then MQ4. Alright, can you do it for each? Okay. Alright, done. Can you do that? Q2, so what you do is, let's find Q2. What's Q2? 9.61 minus 9 over, okay, 3.1. Please write the exact step. Okay, subtract the top, you get 0.61 over 0.1, which is 6.1. And we'll do the same again. Alright, next one, 9.0601 minus 9 over 3.01 minus 3. What do you get? 0.0601, which is equal to 6.01. Right, I can do it without a calculator because when you divide by 0.01, it ends up moving the decimal point 2 places to the right. And then we'll keep going, 9.006001 over 3.001 minus 3. We get 0.001 at the bottom. Top is, oh sorry, forgot to minus 9, 0.006001. That will be 6.001. So now you see a pattern. Okay, good. All right, let me see. Oh, it's been, yeah. I may finish that and then continue the other bit on Monday. All right. Okay, now can you write the gradient here? So the first one is 6.1, 6.01, 6.001. So let's write it down and then we're going to talk about it. Let's pick a bigger screen so you can see. All right, so hopefully you can see the working out. So what's happening there? See the red line? The gradient is approaching a limit. And what do you think the limit is? 6, right? It's getting 6, right? This part's getting smaller, right? So that 6 is the gradient of the tangent. That's how we differentiate by first principle, by making Q as close as we like to the point P. Yes? Now, when that process, as the process goes, what's happening to the numerator and the denominator of the gradient is approaching 0, right? Both of these are getting smaller. But in such a rate, the ratio does not approach 0, it's approaching 6, right? So that's why you have this notation. So we have this delta y over delta x, right? This is the change in y over the change in x, right? And both of these is going to approach 0. But when they approach 0, the ratio does not approach 0. If the ratio approaches dy over dx, that's why the dy over dx come from the gradient. Yes? Okay. All right, let's fill this up. So as q approaches p, the gradient of the secant is approaching a limit. And the value of this limit is 6, as we found earlier, right? The gradient at x equal to 3. So therefore, the gradient of the tangent to the curve at x equal to 3 is 6. We worked out without measuring the gradient. We actually worked out using algebra. Yes? But the question is, we're not going to do that each time. That's a lot of steps just for one gradient. How do I simplify that? That's what we're going to do on the next page. Differentiate this by first principle. Okay, so how do you do that? So what you do is this. We start off with a point 3, right? What's the y value? You substitute 3 into x, the y value is 9. Does that make sense? That we call that point P. After we found that point, we're going to find the point Q. And that point Q is, what would that be? It's going to be 3 plus h, right? We're going to go h forward. 3 plus h. 3 plus h, just a little bit before q, before p, right? And how do I get the y value? Just like before, we substitute 3 into y. We also substitute this into this, right? And when you substitute 3 plus h into square, you get 3 plus h squared. Okay, let's find the gradient. Now, the gradient formula of PQ is y2 minus y1 over x2 minus x1. That's your y2, x2, that's x1, y1. And we're going to subtract them by 3 plus h squared minus 9 over 3 plus h minus 3. And we're going to simplify this gradient. So how do I simplify? We have to expand the numerator and collect like terms. Hopefully remember how to expand the perfect square. If you expand the 3 plus h, what do you get? 3 squared plus 2 times 3 times h plus h squared minus 9 over, these two get cancelled, so you have a h at the bottom. Okay, now let's keep going. So the next step is to simplify that. So you get 9 plus 6h plus h squared minus 9 over h. We're going to cancel the 9, right? Okay, so what we do is we're going to get this. Now, how does the secant become the tangent? Let me draw the line there. The secant becomes the tangent when the point Q approaches P, right? So when Q approaches P, that means H approaches, the gap between them becomes 0, yes? So we take the limit. We take the limit as H approaches 0 of the gradient of PQ. So we'll make H as close to 0 as we like. And we've done this limit before, we take the h out. Because I can't substitute 0 yet, because there's a h in the denominator. So we end up getting limit as h approaches 0, 6 plus h, we get 6 as we expected, right? That's the formal step of doing this. Alright, that's a lot of work for just for one gradient. How do I find the derivative using this method? We just use that method to find the gradient. How do you find the derivative? We'll first have to differentiate by first principle. So let's go to a more general formula. This formula is on the reference sheet. Okay? Alright, let's move on to the next page. 1, 2, 3, going to move. Yep. Alright. Okay, let's look at this again. We're going to write down the point. This graph here that you see in front of you, we're going to differentiate, right? So that's the secant. So let's start with that point. This is x comma fx, right? Because that's the y value. That's the formula. We don't know what that formula yet, so we'll call it fx. But before we got x and x squared, now this fx. And then we're going to pick another point. This point is like before, h steps from, this is h step from before, so that's x. So therefore this point will be x plus h, right? So you write x plus h as the x value. The y value is x plus h into f. Yes? So now, like before, we're going to find the gradient. Find the gradient. Okay, let's find the gradient. So the gradient is, let's write it here. So that's Q, that's P. The gradient of PQ, or QP, MPQ equals y2 minus y1 over x2 minus x1. And what happened to the denominator? The x gets cancelled. Over h. Yep. Okay, so you got that gradient. That's the gradient of the secant. That's the secant. And when does the secant becomes a tangent? That's when the h approaches 0. Alright, so let's write this down. So we're going to copy this here. So this bit is when you take the limit approaches 0, h approaches 0, of this. That gives you the derivative. That's called differentiation by first principle. It is on the reference sheet. I want to memorize it as well, but if you forgot, it's on the reference sheet. It's on the reference sheet. You should be able to find out. You should be able to recognize it. Because that's one of the chunky formula, right? So it's on the reference sheet. Now let's use this formula to find the derivative. So this is called differentiation by first principle. So when the question says differentiate by first principle, that's what you do. We'll do this question. Okay, let's look at this. All right, we'll do some practice questions. So f of 4, x squared minus 3x, what do you do? f4 equal 4 squared minus 3 times 4, right? 16 minus 12, 4, on page 14. Okay, on the other hand, if I do this, it's the same thing. What if you go 1 plus 3? Means that every time you see an x, you replace it by 1 plus 3. Does that make sense? Yep. So this 1 plus 3 gets repeated every time you see an x. Which is same as before, right? That's 4, right? You just get 4 squared minus 3 times 4. You still get 4, right? Same thing. I'm substituting 1 plus 3, 2 things into 1 x, okay? All right, how about this one, x plus h? So you just go x plus h all squared minus 3 lots of x plus h. Yes? Right? Does that make sense? This is important because you need to know how to do this. This is put in both. Yes? Won't be bothered expanding this. We'll just leave it as it is. We'll do that on another question. Okay. All right, now, differentiate by first principle means that how do I get the formula f dash equal to 2x? Right? We're going to prove this formula. Prove it. To prove it, we're going to use this formula. Let's write it down. F dash of x equals to the limit h approaches 0. F of x plus h, the more you write it, the more likely you remember. Okay? I wrote it again. Okay, so make sure you write this. We're going to go through it very slowly. Watch this. Next step is still limit h approaches 0. Right, write this first. Okay, all right. Watch this. You're going to put x plus h into this formula. Means that the x are replaced by x plus h squared. Yes? Because I'm putting x plus h into x. What's the second bit? Fx is just x squared, right? So you just write x squared. Once you write that down, the rest is all algebra. So you need to expand, collect like terms. So let's continue. Lim h approaches 0. X squared plus, you need to know how to expand perfect square. It's a useful skill. Like this. I expanded it. Expand. Expand. And then what do you get? Cancel the x squared. And then you write lim h approaches 0, 2hx plus h squared over h. And then you factorize the h out. Like the stuff we did before. And then you substitute after you cancel. H approaches 0, 2x plus h. And what do you do? Put 0 into h. It's 2x, as expected. That's called differentiation by first principle. Is it hard? Not hard. Is it long? Yes. You have to learn it. Yes? We'll do some harder questions. Now, once you get the formula, how do I find the gradient at 3? You just substitute. F dash 3 equal to 2 times 3, 6. Get it? And then we'll do a harder question. Yeah, so I think we'll do one more question and then you do the homework, okay? Yeah. Now, I think you need some practice, okay? You need to practice. Okay, I really want you to practice before you leave the classroom today. All right, next page. All right, this one. Now, this is a question likely to be asked in the exam where there's more than one terms. Okay, let's watch this. Okay, watch this. So you got fx equal. Now, if they don't have an fx, just write fx in. Right? Write down the formula first. Lim h approaches. Now, actually, I forgot. Leave it there. I just want to. Don't rub off. Just write f dash of x equal to the limit because I'm finding the derivative. Remember? Equals to. Just write this formula first. Always write the formula. Okay, write this step first. Every step you should put in. Do not take out any step. Just this, all right? Easy. This is the third time or fourth time you wrote it, so hopefully it's more better in your memory. Now, if I'm going to ask someone, let's say Anthony, can you tell me what the derivative is? Not by first principle, just by looking at it. Yeah. So it's a way of checking. So if I got this answer at the end, means you got the 3 marks. Get it? All right. So that's a way of checking. But that's not your answer. You got to show all the steps. Remember, keyword, first principle. Okay, now this is the tricky part. Watch. Put a very long denominator. It's going to be very long. Okay, watch. Okay, now x plus h. I'm going to put it into 2 places. X and x, right? So you write x plus h squared. That's just the first term. Minus 3. Again, we see the x replaced by x plus h. But the 2, nothing. You still have to write the 2, plus 2. Does that make sense? Every time you see an x, put an x plus h in. There are 3 terms. Just from here. This bit gives you 3 things. Yes? And then we now have to minus. Now this time you need to put a bracket because there's more than 1 term you have to minus. Minus this whole thing. X squared minus 3x plus 2. Get it? This is from here. Does that make sense? Okay, so you need to do that a few times. I suggest you, after I finish this example, redo this example. If you got this right, you should be able to do another one. Okay, now let's do this. Equal. You need to keep writing the limit. This is the way you do things. Do not stop writing the limit. Write the limit all the time. Yes, like that. Expand. How do we expand? Perfect square. A squared plus 2ab plus b squared. Then expand the negative 3. Negative 3x minus 3h plus 2. And then you have to expand the negative. Negative x squared plus 3x minus 2. Yes? Okay. Now, what do we do? What should we do next? Collect like terms. Now, there's a trick to it. Every term that doesn't have a h in it will get cancelled. Can you see the x squared doesn't have a h? They get cancelled. The 3x doesn't have h cancelled. So all the purple term gets cancelled, right? Can you see all the purple term gets cancelled? So you should only be left with everything with a h in it. If not, you made a mistake. So on the numerator, every term must have h. If there's a term without h, you made a mistake. All right. Okay, good. Lim h approaches 0. Take the h out. Oh, that's an x. Sorry. Over h. Right? Cancel. It seems that you have finished before me, which is good. If not, keep watching. 2x plus h minus 3. Replace the h by 0. Do you think we did it correctly? How do I know I did it correctly? Yes, we can check it this against this, right? So we got it right. So that's how we're checking the exam. All right, so now do 8.1, 8.2, 8.1, 8.3, 8.4. We'll do 8.2 on Monday. All right, good. Actually, I should make it a bit bigger. Sorry. All right, that's it.